I'm Stephen Foskett, organizer of Tech Field Day, and we're here in Austin, Texas, with a group of international delegates brought in from around the world to learn about technology in their space. Today we have ZeroStack presenting, and if you'd like to learn more about this, you can go to techfieldday.com, and you can find a lot more videos like this at youtube.com/techfieldday.
My name is Ajay Gulati. I am one of the co-founder and CEO at ZeroStack, and today I'll be talking about self-driving private clouds, what they mean, and how we really enable them. So let's start with a little bit of cloud landscape. Where are we in terms of getting access to cloud technologies? What I mean primarily is infrastructure as a service and platform as a service in this case. And we have seen a shift over the last 8 to 10 years going from virtualized IT, where you are essentially virtualizing your applications, to a public cloud where you are really using self-service based cloud, pay-as-you-go model, to a private cloud where you are actually building some cloud on premises. And we have seen different vendors in that space. Obviously, on the public cloud side, we have 3 dominant public clouds in terms of AWS, Google, and Azure. Virtualization, we know dominant vendors there in terms of VMware, Microsoft. And now a lot of vendors are trying to get into the private cloud space with different models of actually delivering private clouds. So let me go a little bit into what are the different ways of consuming the private cloud. And in the talk today, we are going to do some analogy with the car world out there, because some of the things fit very nicely. So if you look at the evolution of cars, we started with the model of this buy and drive, where you buy the car, you own the car, you drive the car yourself. Then we have this another model, which is you have the car, but then somebody else is taking care of the car for you. They are driving you around, they are taking care of maintenance and everything else, and you are just using the car. And now we are looking at the world where it's self-driving cars, autonomous vehicles, and there is a lot of machine learning and artificial intelligence driving these vehicles, and we are seeing that in our day-to-day lives as well. I'm sure a lot of people here use Google Home or Alexa or other virtual assistants, and there are a lot of other areas in our lives where machine learning is being applied. So if I look at private cloud, we see a very similar evolution there, where you start with the software solutions where you can design, build, and operate it yourself. And you can actually buy a software stack from many of these companies, or you can buy converged software and hardware stacks, and you can build and operate the cloud yourself. Now, obviously, that becomes a pretty daunting challenge, and not everybody is up for doing that, depending on their scale, level of expertise, and how much IT infrastructure and admins they have. So the next model is essentially a managed private cloud, where somebody else is taking care of the complete cloud for you, but you are just consuming the cloud. You don't have to deal with day-to-day operations, day-to-day management, and other complexities. And finally is the self-driving private cloud, which is what we have built at ZeroStack. And I'll walk you through in the next 2 hours, what does it mean to build a self-driving cloud, and what are the different pieces that are required, and then go over how we are achieving that, and go through demos to show different parts of the technology. And if at any time, if there are any questions, comments, feel free to interrupt. We'd love to have questions. Okay. So let's look at what does it take to build a self-driving cloud, because whenever you are building some technology which is as complicated and sophisticated as an autonomous vehicle or a self-driving cloud, you need to be able to do a lot of things and not just apply machine learning to one specific task. So I start with just the building the cloud itself. So you need to have a way to bring up the cloud automatically without a lot of human intervention, and have the cloud be up and running very quickly without you having to sort through a 100-page manual and figuring out how to build the cloud. Once you have set up the cloud, it's not something that sits in a silo. This is where your applications are going to run. This is where your users are going to interact. This is where all the workflows would be there. So you want to integrate that with other clouds and other existing systems. So what I mean by other clouds is it could be another public cloud, it could be another private cloud. What I mean by other systems is you may have already existing storage where you have a lot of data, and you want this cloud to be able to access that storage. Or you may have an existing virtualized environment from where you may want to migrate applications, or you may just want to integrate with your AD, LDAP, or other IT systems. Now, once you have done the integration with other systems, the next thing you want to do is obviously consume the cloud, where you want to be able to deploy applications on the cloud. And it should allow you to basically deploy applications as a whole and not just doing things at a VM level. And ideally, you should be able to describe your application or infrastructure as code so that you can deploy a multi-tier complex application with a single click if possible. The next thing is, once you are running your apps on the cloud, you want some sort of real-time alerts, events, stats, so that you know what's going on. If there is any problem with your application, you want to be able to monitor it. If there is any performance issue, you want to get some live stats. So you want some real-time monitoring so that the person who is deploying the application, they can do the monitoring of the infrastructure. The next thing you care about is, now you have applications running, you can monitor your apps, but over time there is bound to be some failure. On day 30, day 90, day 120, once there is a failure in the system, and it could be a hardware failure, it could be a software failure, this is where it gets very complicated, that typically you would have to deal with a lot of the failures themselves, and that's where the self-driving nature of the cloud comes in, that how many failures and what kind of problems the software system completely masks from the end user. And the end user here means the actual user as well as the admin who may be doing the high-level administration for the cloud. And they should not have to deal with a lot of these failures happening in there. Now, once you have the cloud up and running for, let's say, a couple of months, the next thing you want to be able to do is make decisions in terms of what's happening overall in the system, what about the capacity consumption, when would you need to add more capacity, are you running it in the most efficient manner, are you running your apps in the right size of VMs. There are a lot of decisions that you can make to really optimize the system over long-term monitoring of the system. You may not be able to make some of these decisions by one day of metrics, but once you have observed something for a month or two, you can make a lot of decisions to really improve the cloud infrastructure itself. Now, there is one thing which is missing here. Let me just ask, what do you think is missing? I have gone through 6 things here. There is one more thing I'm going to show. Any guesses on what I haven't mentioned which you think should be there?
Profit.
And Steve here is going to give out $1 for the correct answer.
I said profit.
No,
Profit.
I'm money motivated.
Profit? Okay, I mean, that's the ultimate goal, but this is something that you would have to deal with yourself otherwise.
Profit's the 8th layer.
Yeah, the 8th
The
layer.
old 10?
It's the all layer.
Retirement? That's close enough. I would say that is $50.
I'm sure I've got some scissors here.
So
Ooh, bribery.
I think this is something which is
Corruption.
one of the biggest pain points in a cloud infrastructure, which is how do you deal with upgrade of a cloud. It's like you're running 100 servers, you are running a lot of applications on it, and now you have to deal with upgrade of that environment. And if you have built this environment with server, storage, networking, virtualization stack, in order to do the upgrades, you may have to follow a lot of recipes and dependencies, and you have to deal with a lot of stuff to be able to upgrade something like that. And this is one of the things that a lot of customers talk about, that they use technology, but once it comes time to upgrade, it becomes a much more manual and lengthy process. So this is what I'm going to walk you through in terms of how we are achieving each of the 7 things. And let me first give a little bit of overview of the solution, what ZeroStack does, how the solution is structured, and then I'll walk you through how exactly we are achieving these tasks. So previously we were at TechField Day. It was about a year ago, and there we sort of unveiled our 1.0 platform, which is essentially, we have a ZeroStack cloud operating system that converts your bare metal servers into a highly resilient cloud. Once you rack and stack a couple of these servers, they talk to the ZeroStack SaaS portal, and all the consumption happens through the SaaS portal. So the idea was that you take a bunch of servers, you rack and stack them, You give them an IP address, they talk to the SaaS portal, you configure the cloud in about 10-15 minutes, and you start consuming the cloud. Now, since then, we have built a couple of things in terms of technology, and let me just walk you through what are some of the key things that we have added in last 1 year. So the first thing that we added was the VMware workload migration, which essentially, when we talk to a lot of customers, they are running on some existing virtualized infrastructure, which typically in most cases is VMware. So when they want to test out this new cloud, we need to be able to migrate the workloads quickly on ZeroStack and show how it would run on ZeroStack, how their workflow would look like, and their day-to-day processes. So we have automated that process of doing workload migration, and I'll give a demo of that further along in the talk. The next thing is a lot of customers have existing external storage investments. So they may be using a NetApp or a Nimble Store or a Pure Storage or EMC. We basically work with all of those existing storage vendors, and we show that as an additional pool of storage. And in some cases, it is required because of investment. In other cases, because of a specific feature that they need from that storage array, which is the data management feature that they may require. The next thing that we did was integration with AWS itself. So you can now integrate ZeroStack Cloud with AWS, and you can migrate workloads from AWS to ZeroStack or ZeroStack to AWS. And that allows you to essentially take benefit of this hybrid model where you are running the cloud on premise, but from the same SaaS portal, you can actually migrate back and forth from AWS. And on the SaaS side, that's our layer where we are collecting a lot of data. We have made a lot of improvements on the cloud-based monitoring and operations, and one of the main things that we have added is an AI suite for self-driving cloud. And I'll show what are some of the capabilities that we have built, but it's essentially, since we are collecting data, and in this case, not just from one customer, from a lot of customers in the same layer, we can build models in that cloud layer that we can then use to improve the efficiency and the overall cloud for all of the customers, because we have a big data cluster that we can leverage for that. So any questions so far?
Yeah, I was going to ask you about your external storage integration. Is that, I don't know how the product really works that well, but are those the only supported hardware vendors that you have for storage integration, or?
So I think these are the ones where we have done currently testing with, but if there is another vendor, we are working with a couple of other vendors also to add. So I think this list would change pretty quickly, and it takes about 2-3 weeks for us to do that testing. So it's not something which is a long process.
Okay.
Yes.
The VMware migrations along with that, does it convert them into like QCal image, or is it going to keep it in a VMDK, VMware type?
It's a conversion. So essentially, we are converting from VMDK to QCOW, and we are also putting the KVM drivers in there. So all of the conversion, driver replacement, all of that is handled by our process.
Is it able to strip out the VMware tools as part of that?
It can, yes. Okay. So it will take care of that as well, because otherwise they'll keep on looking for ESX underneath, and that creates problems sometimes.
Thank you.
Okay, so let me go a little bit more into the technology before we jump into the demos. So one of the main things that we have spent a lot of time on is the learning engine, or what we call as the Z-Brain, which is running as a private cloud that we are hosting in different data centers. And this is essentially a big data processing cluster where we are collecting telemetry information in terms of stats, events, metrics. And on top of that, we are building models and doing machine learning so that we can provide insights as well as some features that would help people improve their applications as well as overall cloud efficiency. Now, when you look a little bit deeper into the engine, over the last 1 year, we have analyzed more than 1 million objects, and there are two kinds of analytics that we are running on it. One is long-term analytics, where we look at data worth 1 to 3 months, and we are making decisions, for example, capacity planning, what you should be buying and what type of infrastructure you should be buying. And there are a lot of other such examples. For the real time, we are doing more real time detection, for example, detecting anomalies when they happen. And we are leveraging both Spark and MapReduce jobs to be able to do the real-time and batch processing here. Okay. Another key feature that our solution offers, which is very easy given our overall design, is if you want to have a multi-site cloud deployment, where you want to have a cloud which could be a small scale but on multiple sites, just because you have either different teams on different sites, or you have, it's like a retail location, you have multiple retail locations where you want to run a certain set of applications. You can deploy that, and a single team can manage all of these in a much more consistent manner from a centralized SaaS portal. But on each site, you are essentially running a self-healing private cloud, which is closer to your user, so it gives you much lower latency, much higher performance, and it can interact with your infrastructure if you have on the site itself. Now, going a little bit into the design and technology, what exactly we are doing and how we are doing it. So the core of the technology on the on-prem side is the cloud operating system. So we take a bare metal machine, it could be a Dell, HP, Lenovo, Supermicro, you put ZeroStack cloud operating system on it, it completely takes over the machine, storage, networking, all the pieces, and all the cloud management software hypervisor is built into the operating system. So one thing to note here is that there is zero software install. You are never installing any net new software once the machine is imaged. It also provides you a SDN layer, which is the software defined networking. So if you want private networks, if you want firewall as a service, if you want per VM firewalling, all the SDN features are built in, and it also takes over the local drives, and it gives you both local storage, which is not replicated, and clustered storage, which is replicated. And as I go through the demo, I'll go through what are the different pools that we have created, and they are based on the real use cases. So if you have both SSDs as well as hard disks, we would have a local SSD pool, which is not replicated across machines, for workloads like test and dev, for workloads like Hadoop, Cassandra, or any NoSQL store that you run. If you are running something that requires reliable storage, for that you can use a clustered either based on SSD or based on hard disk. We are not doing any tiering between them right now. It's either you pick a SSD based pool or you pick a hard disk based pool. And that just depends on the use case, whether you want more IOPS or you want more capacity. So for example, if you are looking for a pool for your image store, you just pick something based on hard disk. You don't have to pick SSD based pool.
Are you able to analyze existing workloads in a VMware environment and be able to make an intelligent decision on how we should be carving up our storage for something like that?
So when you are moving from VMware to ZeroStack, at that point we give you the option, what kind of backing do you want? Mm-hmm. Since you are moving at that time, we don't know what workload you are running right now. So we'll give you options where you want the virtual disk to be, whether it's going to be SSD or hard disk based pool. But once we have seen it running for some time, mm-hmm. after that we can give recommendations in terms of this VM is doing a lot of IOs versus not doing a lot of IOs. But it's just that we are not monitoring the stats from VMware to be able to analyze it on day one.
Okay.
And in our case, you can also move the virtual disk from one pool to another. So let's say on day one, you did not pick the right pool. But once you see that you should have picked SSD instead of hard disk, you can change the pool for that virtual disk later.
Yep.
Okay. Now, another piece of software here is the cloud management software. This is the layer that also has a distributed control plane. And that is something which is very unique to us, where once the cloud comes up, each of the servers, they are running monitoring of all the services that build the cloud. And if there is any failure, this cloud management software layer would heal the system. So that's where the zero touch or self-driving nature of the cloud comes in. So it's not that you don't have to install the software. It's also that once it's up and running, it is self-monitoring. So we are monitoring all the software services on a few second interval by not only looking at the health of the service, but also making calls to make sure the service is working fine. And we are also monitoring all the hardware infrastructure and giving high availability on that. So I'll go through a demo where we'll see that when some host fails, how the system heals itself. Okay. And another thing I want to point out here is that when you run a bunch of ZeroStack nodes, that is the full cloud. There is no separate management cluster. There is no separate operations cluster. There is no separate data analytics cluster. Essentially, we are running everything. Each node is a compute node, and we are carving out a small piece from that node to be able to run any management service. So if you think of in VMware terms, you are running ESX hypervisor, and then all of the services that you may need are distributed across ESX hypervisors. vCenter could be running on one machine, NSX could be running on another, VCOps could be running on third. Everything is distributed, and if there is any failure, it would heal itself. You would never have to go in and say, oh, this software service failed, let me go and restart something. So that's the main distinction. Now, once you rack and stack these machines and you give them an IP address, they talk to the cloud gateway, which is the ZeroStack private cloud, and this is all over HTTPS, only outbound. And on the cloud side, what we are running is essentially a large data processing cluster, where we are collecting all this data, putting it into a large NoSQL store, and on top of that, we are doing both real-time as well as long-term processing.
Does that mean that every single host that is running ZeroStack needs internet access to access the cloud gateway?
Yes, outbound HTTPS.
Okay. Is it, I guess, would it be possible, or is there any plans to just have like maybe one or just two? I mean, the idea that, I mean, like, you know, coming from financial services, having like getting a firewall team to open up, you know, this many hosts, depending on how many hosts it is, trying to access the internet is not likely. So being able to funnel that through, like, you know, I have my own gateway on one side. All of the hosts talk to that gateway, which talks to your cloud gateway, which would be easier to get through firewalls.
True. Actually, we have some POCs going on at a financial institution, and there they basically gave us a HTTP proxy. They said everything has to go through the HTTP proxy, and that you can configure on each of the hosts. So we can either go directly over port 43, or we can go via an HTTP proxy. And all the communication is HTTPS, so proxy really doesn't block anything. And if there is real large deployment, if somebody says we are going to run a 200 node cluster, and at that point we can run something on-prem, I think we can discuss that as well. It's just that there is effort in running this on-prem, and it doesn't make sense to do it at a smaller scale.
Yep.
Okay. So in terms of consumption, all the consumption also happens through this. So one thing I want to highlight is there are a lot of vendors these days where they have a portal where you log in to just see some things about the box. For example, if you look at a lot of storage vendors, they have a cloud portal where you can log in and they'll give you some insights about the storage. But the consumption is a local consumption. You go to the local UI and you create your volumes or LUNs, whatever you need to do. In this case, the cloud is not just a place where you go to look at dashboards and to look at your stats and being able to analyze things. You are also consuming the cloud from the SaaS portal. So when a user or a developer wants to create workloads, they would log into the SaaS portal, and at that point they can start running the workload on the existing on-prem infrastructure.
If I lose the uplink to your cloud, do I still get alerts, and do I
That's
still get
a
them?
great question. So if you lose connectivity to the cloud, what happens in that case? So one thing to note here is the overall cloud management software, everything is running on-prem. So you not only all the workloads would keep on running, you also have a local endpoint where you can connect and you can run API scripts against it. And you can run new workloads, you can look at your existing workload. What you would miss is whatever telemetry, analytics, dashboards that we are providing from the SaaS portal itself, those pieces you won't be able to see once you lose connectivity. But when the connectivity comes back, it essentially would restore the connection. It would send the data that it would keep on storing in the local cluster in the meantime. And after that, you would be able to see all of that. So there is going to be limited functionality, but the basic functionality is always going to be there. Yeah.
Can you clarify something more about the hypervisor? You are using KVM, but which kind of certification do you have for workloads? For example, is Windows certified on it? Is standard KVM? And which kind of integration do you have with, for example, backup product or other technology that must interact with the hypervisor?
So we are leveraging KVM as the hypervisor. It's optimized, and we have made some changes to improve the performance of the hypervisor. In terms of operating systems, we support RHEL, CentOS, Ubuntu, SUSE, Windows, all of these, they work fine. We provide drivers for Windows, so if a customer is leveraging Windows VMs, they can use those drivers that come.
You provide the drivers are not the standard KVM drivers from...
So we are leveraging Canonical for those drivers themselves. So it's not that we are building all of that ourselves, we are leveraging their drivers.
Well, I guess to expand on that, integrations with, I guess, other backup products, is there anything that would integrate natively with ZeroStack?
That's a great question. So in terms of backup, we have a backup built in now. So all you need is any kind of NFS storage. If you can provide that, then we can snapshot and back up your full VMs or volumes on that backend. If you look at existing backup products like NetBackup, Commvault, others, as long as the product supports OpenStack API-based integration, they can work with ZeroStack. I think most of them, when I talk to them, it's in the works. I don't know if many of them they're already supporting, but we have an inbuilt backup solution.
Yeah.
Yes.
Going kind of back to the VMware stuff with high availability and tools that I'm used to for my stateful VMs, is this working with the assumption that I'm working with stateless VMs that have application availability, or could I move my existing, let's say, a Windows workload over there that needs the machine to be highly available instead of just the application?
That's a great question. So it is not making any assumptions about being stateless. You can move the VM with the state onto ZeroStack, and we provide high availability for the VM, and the high availability of the persistent state comes from the reliable storage itself. And that can be on ZeroStack, or that can even be on some external storage. That wouldn't matter. Yeah.
So what's in your, what's the App Store? What's the App Store?
So Z App Store, essentially, when you log into the cloud portal, it shows you about 40 to 50 pre-built application templates so that you can quickly deploy those applications. So some examples are, if you want to build a CI/CD pipeline using Jenkins and Git, you can just quickly deploy Jenkins, Git, and configure them, and now you have a full pipeline running. You can deploy a Hadoop template, or you can deploy Cassandra. We have a suite of applications that essentially give you the App Store functionality. And I'll actually go into more detail on each one of these as part of the demos.
Okay. And how are those defined? I mean, can you create your own?
You can
YAML
create,
or whatever it may be.
yes, it's essentially based on YAML. It's CloudFormation template, so the same template works on ZeroStack as it will also work on AWS. And we have also helped customers create their own custom templates. So if you are building, let's say, an application using MeanStack, we can help you create a template for your specific app so that you can click, and now your developers or support team or sales team, whoever wants to bring it up, they can bring it up quickly.